In this session, we are going to learn about how to check whether a given word belongs to a context-free grammar or not, using three techniques: derivation, parse tree, and then reduction. A small recap on what a context-free grammar is. Context-free grammar is a four-tuple: V, the set of non-terminals which can be expandable; T, the set of terminals that is not expandable; P, the set of productions of the form non-terminal gives combination of terminals and non-terminals followed by the start symbol from which the derivation has to start. For example, if V has only one symbol S and T has two input symbols A and B, the productions are three: S gives A as B, S gives A, and S gives B, and the start symbol is S. So this grammar will generate all palindromes of odd length. Let us see the first method of checking whether a given word belongs to a language generated by the context-free grammar or not. Assume this is the given grammar. There are three productions. It's a subset of grammar which is used to generate all arithmetic expressions. Assume the word id plus id star id. Our task is to check whether this W belongs to this grammar or not. The first method goes like this. Let us start from the start symbol, because always it's a mandatory requirement to start with the start symbol. So the word that we are going to derive is id plus id star id, and hence, as usual, the input buffer will start scanning your input from left to right. Check the first symbol, it is id. Try to map it with the right hand side. Yes, we have a production E gives id, but if you have used this production, only one operand id could be generated. Okay, but this equation has combinations of more than one operand with plus and star operator. So you can generate like this: E gives E plus E, which is the first equation in our CFG. Both are non-terminals. You can see this E is a non-terminal, this is a terminal, and this is a non-terminal, and hence this can also be expanded and this can also be expanded. Now coming to the leftmost non-terminal, if you check, we are in need of id, okay, and followed by a plus symbol. Here plus symbol is already there, and hence we can use the production E gives id. Okay, so instead of E we have substituted id. Now again, if you look at the equation, id is there, then you move your input buffer to the next input symbol, then plus is also mapped, then the input pointer moves to the next symbol, again it is id. So if you substitute E by id again, the rest of the equation cannot be obtained, and hence we have to use E gives E star E to map it with the required word, and hence this E will get expanded using this equation. Sorry, instead of this minus you assume it to be star. Yeah, so this is star, and now this E gets expanded to E star E. Now after that, these two are the input symbols that are matched. Now your input pointer belongs to here. Now we can see here there is a non-terminal over here. Okay, so we can substitute E gives id in place of E using the production E gives id. So we'll be left out with this thing. Finally, again, this non-terminal E can be expanded to id using this production E gives id. So we'll be left out with the word. So as and when the mapping happens, you can move on, and now all the symbols of your input word gets matched. So we have started with the start symbol and we arrived at the word. So this is a case kind of top-down methodology. Okay, so why? We start with the start symbol and end up with the word, and hence it is a top-down methodology, and this concept is what we call as derivation. So we are trying to derive the word from the start symbol. Hope this is clear. Now let us move on to derive the same word using two different methods. Now that we have E plus E, as usual, the leftmost symbol gets expanded to id using the production E gives id. Then again, from the left, if you look at, this is the leftmost non-terminal. id and plus are terminal symbols. So E gets expanded to E star E. Using the production, E gives E star E. Fine. Now from the left, this is the leftmost non-terminal. So using E gives ID, again that will get expanded to ID. Finally, from the left, this is the leftmost non-terminal. So E gives ID could be used in order to arrive at the word W. This is derivation, that's what we have seen earlier. But the case is that even though there are multiple non-terminals in a single format like this, we are just substituting the leftmost non-terminal at a particular point, and hence this kind of derivation is what we call as leftmost derivation. On other case, okay, so here there are two non-terminals. Okay, instead of deriving the left, if suppose I derive the rightmost non-terminal at every point of time, so what is that we have to use? It should be E gives E star E, because the pattern of word that we are in need of is ID plus ID star ID. So in order to have this, you have to expand E by E star E. So you can see this E gets expanded to E star E. Now again the leftmost non-terminal is this. So using the production E gives ID, it gets expanded like this, right? Again using E gives ID, the rightmost non-terminal gets expanded. Then again E gives ID, the rightmost non-terminal gets expanded. So the same word can be reached using this corresponding procedure also. What's the difference between these two? Here every time the leftmost non-terminal is being expanded. Here the rightmost non-terminal is being expanded. Fine. So this kind of derivation is what is called as rightmost derivation. So while you are using that concept of derivation, either this, which is called as LMD, the leftmost derivation, or rightmost derivation, which is called as RMD, must be used. Combination should not be used. So one cannot be this and one cannot be this. For every string, there will exist an LMD and there will exist an RMD. In worst case, when only one non-terminal exists in a production, we say LMD is equal to RMD. But otherwise, when there exists a word, there will exist one LMD and there will exist one RMD. One more important concept to understand. This is the start symbol from which we have to start, and this is the word which we are about to arrive at. In between, during the course of this derivation, we will end up with different equations having combinations of non-terminals as well as terminals. You look at the word, it is just a combination of terminals, but in between you have lot of structures which is a combination of terminal as well as non-terminal. This is what we call as sentential forms. Sentential forms. So the sentential forms belonging to leftmost derivation or left sentential form, and which is belonging to rightmost derivation are called right sentential form. Hope derivation is clear for you. We move on to the second method. Okay, let us consider the same grammar. Again, this is star. Let us consider the same grammar and the same word. Okay, so this method is again a top-down approach. Okay, but a graphical approach. Now we have to start with the start symbol. Just you have to use any of the productions to arrive at the word. So initially we can use the first production to expand E to E plus E. This is the start symbol. Again, this E can get expanded to ID using the third production in order to map ID plus. So this can get expanded to E star E using the second production. Finally, this can get expanded to ID and this could get expanded to ID. Now, how do you identify the word that is represented by this structure? Start from the leftmost leaf node, move to the rightmost leaf node, reading all the leaf nodes on its pathway. So this is 1, then we have plus, then we have ID, then we have star, then you have ID. And this is the word that this particular tree structure generates. It looks like a tree structure, and hence this concept is what we call as parse tree. Again, it is a top-down approach because we start with the word start symbol and end with the word. There will exist a parse tree for leftmost derivation and rightmost derivation according to how we draw the parse tree. Then we'll move on to third method. Let us assume the same grammar along with the same word. Now the concept is a bit different. We are going to start with the word. Okay. Here the word we are trying to arrive at the start symbol. This is bottom up approach. Right? Every step you have to try mapping the symbol with the symbol on the right hand side. If there exists a mapping, reduce it to the left hand side. That's the concept of this. Now you can check whether this gets mapped onto any of the right hand side. Yes, there is a mapping for the third equation. So this ID, I can replace it with E. Now from the right side, this is the terminal symbol we do have. Again, there is a mapping, E gives ID, and hence it gets reduced to E. Now this E star E together is getting mapped to the second production, and hence it could be reduced to E. Now that this ID is there, so E gives ID, so this ID gets reduced to E. Finally, this entire equation using the first production E gives E plus E gets reduced to E. This procedure of where we start with the word and try to arrive at the start symbol using the bottom up approach is what we call as reduction. Okay, so these are the three methodologies: derivation, parse tree, and then the reduction is available for checking whether the given word belongs to the context-free grammar or not. To consolidate, we have the context-free grammar. In order to identify whether the given set of words belong to the language of CFG, we have two approaches. One is top-down. Top-down means from start symbol to word. Then we have bottom-up. So this is from word to start symbol. Under top-down, there are two approaches. One is derivation, another one is parse tree. In derivation, we have two methodologies, leftmost and then rightmost. And in bottom-up, we have this methodology which is reduction. Hope you are clear. Let us move on to do two examples. The first example, given is a complete grammar used to generate all sort of basic arithmetic expressions. You have plus, minus, star, slash operator, parenthesis, and then the operands. There is a given word. Using derivation, parse tree, and reduction, we need to check whether W is part of grammar or not. So, let us take this word ID plus ID slash ID plus ID. This is the W. First, let us use derivation, the first method. So, what to do? We have to start with E. If you want, we can write down the grammar also. E gives E plus E, E minus E, E star E, E slash E, within bracket E, and then ID. So all is E gives. Yes, this is the given grammar. Now, let us do leftmost derivation first. E we have to start with because that is the only non-terminal that is available. Initially, we are in need of a parenthesized expression. So, if you choose this expression, then you cannot add up this particular suffix to this. So, that is not at all correct. So, we need to have an expression with parenthesis followed by slash. So, I am going to choose the fourth alternate, which is E gives E. In the next step, since it is leftmost derivation, this can get expanded to E. Then in the step, since this left parenthesis and right parenthesis are terminal symbols, this can get expanded to E plus E. Fine. So again, this is the terminal symbol which has to be expanded using E gives ID production using this. Then this is the leftmost non-terminal as of now. So id plus id. So you look at this word within bracket id plus id followed by slash gets mapped. So after that, this is the substring we are in need of. So it contains plus and hence the corresponding production has to be used. So id plus id slash e plus e. Fine. So this is the next non-terminal we do have. So id plus id slash id will be there plus e will remain as it is. So again you have e, id plus id. Yes, we are able to arrive at the word and hence this is part of the grammar. The same when you want to RMD. So again e gives e slash e, either e slash e you can take, or if you think you have any other provision to do that, that is also fine. Let me start with e plus e this time. Okay, so e plus e, since it is RMD here, e is there. So since after plus we are in need of only id, I can substitute it with id. Then this e has to be expanded to this prefix which has slash symbol. So this e could be expanded to e slash e plus id. Fine. So this is the rightmost non-terminal now. So what is expected before plus is another identifier, that is an operand. So e slash id plus id. So this suffix part gets mapped as of now. So we are in need of only this parenthesized expression. So from the right, this is the non-terminal we do have. So just expand it to e gives id plus id. Now this is the rightmost non-terminal again. So it will get again expanded to e plus e slash id plus id. So in the next step, this will get expanded to id, and in the final step, this will get expanded to id plus id slash id plus id. So this is the word. This is rightmost derivation and this is leftmost derivation. So you can even use this e slash e over here also. That is also one kind of rightmost derivation. Hope this is clear for you. Let us move on to the second method, which is parse tree. Let me draw two different parse trees to represent the leftmost derivation and then the rightmost derivation. It's not mandatory, it's just for understanding. E gives e slash e. Then this e should get expanded to within bracket. So this should again get expanded to e plus e. So e gives id, this e gives id. Yes, so this parenthesized expression of left bracket id plus id, again left bracket gets over, followed by this slash. Okay, then again we also need to have id plus id after slash. So in order to arrive that, you just expand it using the first production and further by the last production. So if you read out the contents of the leaf notes, fine, it gives you bracket id plus id slash id plus id. Just have a look at the RMD that we have used. Let us draw the parse tree for that. So it is e plus e. Fine. So again this e will get expanded to id and this will get expanded to e slash e. So this will get expanded to id. So this has to get expanded to within bracket e. So again this has to be elaborated to e plus e, and finally this will become id plus id. Again the same procedure, the leftmost node, left bracket followed by id plus id, right bracket slash id plus id. Yeah, this is the word that is generated by this rightmost derivation or the Parse Tree. The third method that we have learned is reduction. How to do reduction? You take the word id plus id slash id plus id. Let us proceed with left to right. So this id could be reduced to e plus e gives id. So the rest of the things will remain as it is. Now from the leftmost, this is the terminal symbol that gets mapped onto the right hand side. So this will be like e instead of id. id plus id. Finally, if you see, e plus e has a mapping on the right hand side of the first production. So it can get reduced to e. So we'll end up with this, and this is the mapping of the fifth production. So it can get reduced to e. Now e slash as such cannot map, and hence this id has to be reduced to e in the next step. And then e slash e is the fourth production, which can be used to get reduced to e. Finally, this id gets reduced, so it is e plus e. Finally, this is e. So from the word, we are able to arrive at the start symbol, and hence the word is of the format. This is how you have to check whether a given word is accepted or not using the concept of derivation, parse tree, and then the reduction. These are the sentential forms. From here to here, or the left sentential form. From here to here is the right sentential form. Sentential form won't include the words. Let us quickly move ahead to see one more grammar. I will leave it as an exercise to you. I'll do only the derivation or parse tree. Rest of the things you can check, and if you have queries, you can write to me. Consider this grammar. Yes gives if within bracket condition followed by statement, else statement. Actually, this is a grammar used to generate your if else statement of your C language. Now this is the given word. We have to use derivation, parse tree, reduction to check whether W is part of the grammar or not. Here if you see, we have A's and B's, which in general has to be considered as the identifier, because from the lexical analysis, A and B will be mapped to an identifier, and hence whatever here ID specifies, that will be your identifiers. Okay, so we can rewrite the equation like if left bracket OP if left bracket id not equal to id, p, else if id greater than id, p. Yeah, this is the word that we have to consider. Let me do leftmost derivation alone. What's the start symbol here? It is yes. So yes has to be expanded to any of the available productions. So if you look at this pattern, it needs both if as well as else, and hence the first production has to be mapped. So if within bracket condition the statement, else the statement. This is the appropriate production we are taking for expansion. Now if and then the left brackets are terminal symbols, we have to expand this condition. So how to expand the condition? We can use the construct for C. So it is id operator id, and then followed by yes, followed else, Yes, it will remain as it is. So the next non-terminal is O. Okay, just substitute according to our requirement. We are in need of not equal to, which is there in the production, and hence it will leave as it is. Now the next non-terminal is yes. So we are in need of P. P refers to print statement. So ID not equal to ID. This will be P. Else yes. Finally, we left out with only one non-terminal. Again, if you see, this is a simple if statement without else. So all things will remain as it is. Only that will get expanded to if of condition statement. So if ID not equal to ID, P else if this will remain. So instead of C, you have to expand like ID, O, ID, followed by yes. Now these things, till this will remain as it is. This O alone will get replaced by greater than. Then in the next step, this L with S will get replaced by P. So finally, we will have the equation not equal to ID. It should go step by step. I am just skipping one step, but you have to write step by step. Okay, one step has to come here. So this is the leftmost derivation. Same in case if you want rightmost derivation, first x has to be expanded, followed by this yes and followed by this condition. That's it. Then while drawing parse tree, again yes gives lot many child will come. So condition bracket left bracket yes else yes. Okay, all these are child that emerges out of your start symbol. Fine. Now this condition will get expanded to OD, O, ID. Then this operator will be not equal to operator. This S will get expanded to P. This S will get expanded to if left bracket condition yes. Then again ID, O, ID. Then this will get expanded to greater than and this will get expanded to P. This is the parse tree for the string. So reduction is simple. This, if you start writing from here to start, that is what we call it as the reduction. Hope you have a better understanding on how to convert the given word or how to check whether the given word belongs to the CFG or not. The automated parsing techniques will be dealt in the subsequent sessions. Thank you.